This is Dr. R. Elavarasi, works as an assistant professor in the Department of Electrical and Electronics Engineering in Ahmed University. Today I will be delivering a lecture on the topic ship electrical systems. Ship electrical system, the alternator plays a major role. It is also called the heart of ship electrical system. The alternator construction mainly consists of stator and rotor. Here, the armature windings are placed in the stationary part and the field systems are available in the rotor part. The main parts of the alternators are stator and rotor. The stator of alternator is not meant to serve path for magnetic flux. Instead, the stator is used for holding armature winding. The stator core is made up of laminations of steel alloys or magnetic iron to minimize the eddy current losses. When compared to DC generator, the alternators are having armature winding, stationary armature winding. The advantages of stationary armature windings are at high voltages it is very easy to insulate since it is in the outside, and also the high voltage output can be directly taken since it is available very close to the outer periphery. The tapping of the generated voltage is very simple and the field exciter winding is placed in the rotor, so low DC voltage is required to excite the field winding. The armature winding can be placed well so as to prevent the deformation caused by the high centrifugal force. The rotor may be of two types, salient pole type and cylindrical type. In salient pole type, mainly the projected poles are used. The cylindrical type, the rotor is of cylindrical in nature and it is used in turbo alternators. Alternator operation, we discuss about alternator operation. The alternator has rotating magnetic which causes the magnetic lines of force to rotate. The lines of force are cut by the armature conductors which is available in the stationary. So EMF is generated. Here the rotor speed is increased to 60 revolutions per second in ship electrical system, and the polarity, everything, the current direction is decided by the pole directions. The ship electrical system, the ship electrical layout plays a major role. It consists of a generator. The generators are run by the prime mover. The generated voltage is of usually 6.6 kV. This 6.6 kV is connected to the bus bar. From that, it is stepped down based on the requirement of the motor, propulsion motor. So it is stepped down with the help of propulsion transformer. So again, the stepped down AC voltage is given to the variable frequency drives where it is converted to DC. Again, AC is converted to DC first, then DC is converted to AC. That AC supply is used to drive the propulsion motor which drives the propeller of the ship. And also the field windings of the motors are excited by the DC supply, that is also taken from the bus bar, and it is the bus bar voltage, AC voltage is converted to DC. That DC voltage is used to excite the field windings of the propulsion motor. Here the equipment which are available below the 440 volt are called low voltage equipment. The equipment which are available above the 440 volt line, that is called high voltage equipment. This harmonic filters are also associated with, connected with the bus bar, which is used to reduce the harmonic content available in the bus bar. The harmonics are nothing but unwanted signal or noise available in the AC system. So that unwanted noise or signal can be reduced, or its magnitude can be reduced with help of the harmonic filter which is connected with the bus bar. The brushless alternator also plays a major role in ship electrical system. The brushless alternator is excited by it is actually available within the main alternator set. The brushless alternator has exciter, rotor exciter, stator, everything is there. Here the slip rings and brushes are eliminated and the excitation is provided not by the conventional DC supply, it is provided by the AVR. This is a circuit diagram for a brushless alternator. Here it consists of, the circuit diagram mainly consists of main alternator and one more alternator. So actually the brushless alternator is a small alternator which is kept inside the actual alternator, big alternator. The alternator, we know very well, the alternator produces the AC supply. That AC supply is connected to the bus bar. That AC supply is regulated with the help of AVR, and that AVR supplies the field system of the small alternator. That small alternator field system is excited by AVR. Then this rotor of this small alternator produces the AC voltage. That AC voltage is converted to DC with the help of the rectifier. That rectified DC voltage is used to excite the field system of the main alternator, so that with the help of this system the field excitation can be varied, so that the output of the alternator can be varied. This is the actual structure of brushless alternator. It consists of main armature, exciter armature, and main field and exciter field. The exciter portion houses a mini generator that develops the power necessary to develop the magnetic field. The exciter field is a stationary direct current which is energizing the winding. This is the winding where the DC magnetic field is initially developed. Even before any voltage regulation takes place, a residual magnetic field exists in the poles. During voltage regulation, DC in the exciter field induces an EMF resulting in current flow in the armature. Residual magnetism. What is residual magnetism? Residual magnetism is existing in the already used machines. So it is the effect of hysteresis effect. So retention of magnetic property in the magnet. Because of this retention of magnetic property, in the initial condition itself, we will be getting the EMF. The exciter armature. The exciter armature is a 3-conductor, 3-phase rotating winding. The exciter armature is located directly inside the stator. The 3-phase EMF is induced in it. That induced EMF is converted to DC with the help of the rectifier circuit. Again, this DC is used to excite the field winding of the main alternator. Rotating rectifier. Rotating rectifier plays major role in brushless alternator. This rotating rectifier is connected with the output of main small alternator. Small alternator produces the AC output. That AC output is given to the rotating rectifier. This rotating rectifier converts this AC to DC. This DC is used to excite the main alternator. Next, we will discuss about the generator in parallel. So, the need for parallel operation is when the load exceeds the output provided by the single alternator. So, the parallel operation is carried out to share total load if it exceeds the capacity of the single machine. Changeover of main and standby generator unit requires a brief parallel period to achieve a smooth transition without blackout. Parallel running is achieved in 2 stages of synchronizing and load sharing. Both operations are carried out automatically, but manual control is also available for backup. The generator already on the bar is called the running machine, and the generator which is going to bring in and which is going to be parallel is called incomer. To smoothly parallel the incoming generator, it must be synchronized with the live bus bar. Here the G1 is already running, and G2 is the incomer. So both are connected to the bus bar. So when the voltages and the frequency, everything is same, that time the circuit breaker is closed. So if both are closed, then both will be sharing the load that will be giving supply to the ship's load. Usually the incomer is adjusted so that the synchronoscope indicator rotates slowly clockwise at about 4 seconds per indicator revolution. The circuit breaker should be closed usually 5 minutes prior or 5 minutes after 12 o'clock position, also acceptable. So when it reaches 12 o'clock position, so it means incomer and already running generator both are having same frequency, same voltage, so that the circuit breaker can be closed and both will be running in parallel. This is synchronizing instruments. So bus bar, here the incomer is G2. G2 is connected, is going to be parallel with the bus bar. So separate voltmeter and frequency meter are available for incomer as well as the running generator. If both are equal, the voltage and frequency of incomer as well as the running bus bar both are equal, that time the synchronoscope will be showing the 12 o'clock position. At that time the circuit breaker will be closed. Then both the incomer as well as the running machine both are said to be called synchronized. Thank you.